Welcome to the fifth and final edition of the BDTI Essentials introductory course to BDTI. We're very happy to have you here for one final time. Today, we're going to be discussing some advanced data analytics techniques, hopefully. So next slide, please. For the final time, just some housekeeping. Please do use the chat and the Q&A widgets during the session. It's always great to have some engagement and some really inspiring questions, so please do feel free to ask away. The widgets are located on the bottom right of your screen, and if you need to enable them, the three dots on the right-hand side, you'll see them there. The session will be recorded and available afterwards. And if you have 2 minutes at the very end of the webinar, please hang around and fill out the survey to share your feedback. And please, let's keep respectful. So today, we'll have a quick recap on session 4, what we did last week. We'll dive into the main content for the final time, data analytics, advanced data analytics. We'll go through some Q&As, and then we'll have a final wrap-up. So one last time, I'd like to pass the floor over to Maria Claudia, who will give a brief introduction about BDTI. Thank you very much and enjoy the session.
Thank you, Kim. Hi, everyone. Welcome back again for our last session. I hope you are still with your enthusiasm very high, and we really hope that you enjoy this journey till now. So, you know, probably after 5 sessions, you are very, very familiar with our big data test infrastructure that, as you remember, it's a very nice data science playground, completely open source, where public administration, this is our main target, can experiment with data for free. So this is something we want to remind once again. BDTI is for European public administration. So if you are a small municipality, a region, or a department, this is really for you. You can just apply. At the end of the session, we are going to recap the light process that you need to follow to benefit from this infrastructure, and also the fact that it's important to find potential partnership in case you have around students, academia, or maybe some interesting companies that can help you in the development of the use case. Really hope that you feel excited, and also you are going to apply for the process. If we move to the next slide, what I just mentioned is clearly summarized now in what you can see. So feel free to apply, feel free to visit our website that, by the way, now has a new look and feel. And you will find there a lot of materials to support you in the definition of your use case. Then let's move to our nice slide with our nice use case. You probably remember very well that we are using this functional use case. We have Zoe and her team, and they are working in this educational department, and they are looking for synergies to start drafting amazing project to support their region that is really, really polluted. From the first session, we were starting helping Zoe. We were trying to find nice data, informative information, and dataset, open dataset mainly, that she could use with her team in order to process and to move forward with their main business question, I would say. Finally, now we have made a lot of progress, and if we move to the next slide, you can see what we achieved session by session. I would say both in terms of tools, but also mainly both in terms of findings and the important piece of the puzzle we were adding little by little. So we start trying to analyze what we found in the web. Mainly we were using publication office open data. Then we start to clean and transform our main data set, and also try to do some extract, transformation, and load process, some ETL. And we try to provide a nice shape of all these data sets and all this information. During last session, we start doing some very basic data analytics on top of the different data set we collect, and also ingest in our database. And today we are doing something that is very, very common if you are a data scientist. So we are going to enrich the main information we collect till now with geographical information. Geodata analytics nowadays is something very, very interesting. And today we are going to provide you a very basic example where we are using OpenStreetMap, that it's an amazing open source initiative. And we are going to understand how to enrich information from the university with some geographical information. Again, don't forget, all the material is available in our GitHub repository, and you can easily go there, fork the repo, also rewatch the videos, and playing with your own use case. Try to reproduce the same main task. Then let's move to the last slide. Yes, this is just a recap of our repo. You will find everything in our GitLab. And I think now it's time to review our homework and finally jump in our last session. So thanks, colleague. The floor is yours. Thanks, Trinidad, and thanks, Schalk.
Thank you very much, Maria Claudia. And today I have Trinidad back in the studio with me. Let's start, Trinidad, with jumping in with the recap of session 4. And as Maria Claudia already showed, last time we got to the exciting part of the data process, where we actually looked at some analytics with different aggregation models, visualization, and show the options how you can report that. And as a quick reminder to everyone, how we got to the insights, we looked at aggregations, basic aggregations, and the concept there is summarizing the data. And you can do that with one group and one category, or multiple categories per group, depending on what you want to find out. We also looked at the pivoting technique, which is probably quite familiar to a lot of people, and that's when you want to break down your information in more detail, so you pivot some rows to become column headings. And last but not least, the concept of visualization is important because not all the insights you can find in a tabular form. There are some hidden things that can only be seen, your patterns and relations, when you actually visualize your data. So that's the high-level concepts. Trinidad, we also brought these concepts into relation with our use case. That's Zoe's use case. Maria Claudia just mentioned it again. It has to do with her working at an educational department in a highly polluted region, excuse me, and they are looking to find partnerships with universities on green projects. So that's the main objective. So we went in and broke it down into different objectives and mapped that to some aggregation methods and possible visualizations that we actually did last week. Maybe you can run us through that again so we just make it clear.
Sure. So after this big goal, we have specific objectives. So Zoe, she needs to perform certain tasks to get insights. So the first one was identify countries with the most universities' involvement in green projects. So to do this, we aggregate the number of projects, and then we plot this data in a stack bar chart. This way, we were able to identify the different types of institutions involved in Horizon funding projects and in green projects per country. So that way we can see a comparison of each country and the number of universities involved in green projects. That was the first one. Then we went to identify the most active EU-based universities involved in green projects. So now we go funnel down one more level, and we only focus on universities. So with the first objective, we saw the big picture, different types of organizations, and now we funnel down to universities. And how we did this, we aggregate the number of projects, and then we plot this also in a bar chart. So that way we can start with a comparison on a university level. Then the idea was to identify trends. So check over the years how the application to projects was done in these universities and this per country. So a good way to see this is by plotting the data in a line plot. So that way we can see the time frame. So country 1, how many projects in this year, so on and so forth. So then we can start seeing different trends in our data. And lastly, we explore relationship between different variables, so different part of the data. So here we check number of projects per university, energy project funding by university, and also the country emission of the CO2. For this, we use a filter plot data in a parallel coordinate plots. So that way we can map different variables in one visualization. So that way we can get more insights from the data.
Exactly, and a reminder here, at this stage of your process, it's the data, the technical side really comes back and meets the subject matter expertise. So again, you can, if you just look at one dimension, maybe one of the first three plots, you could want to go for a university with the most amount of projects. But what becomes interesting, and that's the last plot, and we'll show that just now in the review of the exercises, is that if you start looking at relationship between different dimensions, this can also help you or someone like Zoe make a decision based on what they want to, which criterion they want to preference. Speaking of that, let's now jump into the actual exercise review where we can see the concepts that we spoke about now and the insights and how we actually got to these insights on the data itself.
So let me get the screen from you. Let's come back to our main website, so the BDTI, and also do a quick refresh for the last time. So whenever everyone has access to the BDTI portal, we go to this section of the website, and then we access the BDTI portal. We input our credentials. I already did it, so that's why it pops up automatically. And we go to My Services, and we have all the services deployed. So as we've been working with KNIME, let me open our VM, come back to my data where all the passwords are stored. We select the one from KNIME, copy, and paste the password. So let's jump in straight away into the exercise review for exercise 4, for session 4. So on the instructions that we saw, we have how to access the data from a database. So if we come back to session 3, well, we merge all the data, we push it into our database, and we can connect it again with the PostgreSQL connector. We input all the our credentials, and then what we did here is we do a DB table selector. So now we're going to select the table inside of our database. We select the schema and we select the table that we're going to be using. We can click here and select the different tables that the database has stored. We're clicking OK. And as we run it, we have to read this table now. Perfect. Then we read it and we have our database, our data table, sorry. So here, what we did, we connect to the PostgreSQL database with the pgadmin, and then we connect through KNIME. So now we're retrieving the data from our database. Now, coming back to our aggregations, we're going to start with the basic one, which is when we aggregate the rows. So in this case, we filter first for universities, and then we wanted to count amount of projects per university. So what we did there, we did a row aggregation, and we select the name of the university, and then we aggregate the rows of these universities. So now, if we see on our table, our output, we're going to see the amount of green projects per university. That was the first aggregation. Then, if we want to sort and have some meaningful data, as we saw on the last session, here we can sort by descending order. So that way we can get the university who did the most amount of project, and that way go down. Then we did the group by aggregation. So here we can group by multiple variables at the same time. So we have our main category, which in our case was the name of the university. And then we want to map all the information based on that university. So in our manual aggregation, we tell the program, okay, I want the cumulative CO2 of that country that belongs to that country that the university belongs to, and the different other variables. So for example, total cost of projects, and I want to sum them. So I want to add all together the information, and then I get a final number, which is the total cost. And later, we did a pivot, where it's also an aggregation, as you mentioned before. We want, in this specific case, the different organizations. So then we can map the amount of project per organization. So we select the country first, so the first group, and then the pivoting is going to be organization type in this case. And as we run it, we can see how our table, how was the pivoting. As a last step, we have to rename the columns so that way we have a more meaningful way to see the data. And also we sorted, and then we had our final table. So here we have the country names and the type of organization that they had in that country and the amount of project that each type of organization participated. And the good thing is that we built these really nice visualizations where is actually where we see the insights of our data. So here we can map with the different objectives. So the first objective was to check type of organizations in each university and how much their energy projects. Then we have a detailed view of the universities and the amount of project that they apply. Then we have our time plot. So with a line plot, here we can see, for example, in 2017, each country, how many projects they applied. And then in the last, we have our visualization with the 3 different variables. And here we can click and check, okay, so where is this university? And we can map the different variables about it.
Exactly, and especially the last one, we spoke about how Zoe and her team can use, for instance, that to say, hey, let's go look at the university with the most amount of projects and funding. Maybe this is important for us. We want to partner with experience. Or the other way around, we want to partner in a region with a lot of CO2 emissions. Maybe we want to go in that direction. All right, let me grab back the screen at this stage. Thank you, Trinidad. And then we can go and continue with today's content. So we've now looked at how to get insights. We just showed you how it would possibly look in a report. But since we're working with the regions, and this is something that is very valuable also within the public administration sector, is to map these insights that we already created, but also on a real map. So plot it on a real map. And that's what we're going to focus on today with a little bit more advanced analytics, how to gather this type of data directly via the web, and how to work with this data types, the geospatial or geodata types, now to visualize them. As a reminder, this is session 5 of 5, so this is the last one. Therefore, at the end of the session, we'll have a quick recap of the whole series, so you can see what we did, how it all fits together. But before we get to that, let's focus on session 5, today's session. And Trinidad, if people follow along, as usual, do the exercises, maybe rewatch the recordings, what should they be able to do after today's session?
Well, after today, sign in into the BDTI framework and initialize the tools that we're going to use. So today we're going to use 9 and also pgadmin and PostgreSQL to push the new data that we're going to collect today. Then we're going to understand the fundamentals of REST services, which is a new concept, and we're going to go on detail with this. So that way we can gather data from the internet. So today we're going to start getting that new superpower, which is get data from the internet. Then we're going to retrieve geospatial data because of our use case, and we're going to use an API. We're going to go later on the details of this. And then we're going to append this new geospatial data to our data table. So we're going to enrich our data, and then we're going to visualize it on a map.
Exactly. So first step, before we can enrich the data, we need to get access to them. And it's really the topic of gathering data via the web, accessing it directly. So let's jump into that topic. And Trinidad, maybe let's start with the start, as we always do. Why is this important? How does this work?
Well, why? What's the purpose of this? We access our external data to enrich our data with more information. So for example, in Zoe's case, she doesn't have the latitude and longitude of the different universities. So instead of download another data set and merge it with this data set, she's going to connect to the internet and she's going to retrieve the data. She also can do that with weather, for example, and other information that is on the web. And how she's going to do it? So she's going to extract web data using a REST service protocol. So it's a set of instructions. And we're going to make use of an API, which is the application programming interface. We're going to go on detail just now.
Exactly. So if you haven't heard of REST services or APIs before, no problem. This is exactly the two new concepts that we'll be delving in a moment. But don't be afraid. It's not really that complicated to understand. It's just a little bit of new terminology. So let's start off with REST services, Trinidad. What is it? How does it work? And as a reference, because we're going to continue to refer back to the schema that we will explain on this slide. So what is REST services?
Well, so REST stands for representational state transfer, which is basically a set of rules. So it's a protocol of how two computers communicate over the internet. So then we basically have the internet with data, and we have our machines, and the REST service is a way to communicate with the internet. That's on a very high level. This service offers a web services for clients to communicate with the server. So now we're going to get into this new term that we are clients. So our computer is a client, and we want to communicate with the server, which is on the internet. How we do this? We use an API, which is this application programming interface. And we have a language, which is the HTTP protocol. And we're going to see later that here we have different keywords on how to communicate. And the responses, so if we connect to the server and we connect successfully, we're going to have a response. And that response, that data, is normally going to be a JSON or an XML object.
Exactly. And this diagram here at the bottom really nicely summarizes it up. So your computer is the client. You send something via the internet to a server. If you get a positive response, you get sent back some data. In this case, it's as a JSON object that you can then do something with. Hopefully enrich your data table or something else. So this schema is really important. We're going to repeat it on different levels as we go along. But if you start getting a sense of what this means, then that's what it's all about. So we've now given a high-level overview of REST services, but let's actually break down the parts a little bit more, what's involved there, so that we can then go and apply it in a second.
Yes. So the different elements. So each request from a client, client to a server, to the internet, the way that we communicate has three main elements. The first is the path, which is the location of the web service, so like in the browser. And then we have the HTTP verb, which is the type of operation that we want to perform. So it's like the keyword. I mean, what do I want to do? I want to do A. So that's on the HTTP verb. And then on the header, we have the data for the operation. We're going to go in detail now. And HTTP verbs, the most important for us, for our case, is the get. So we get data, so we're going to retrieve data. And then there's others, which is, for example, post. And then we generate resources or information to the internet, or we put also, we can delete, or also patch, which is like a partially update some resource of information. But for Zoe's case, we're going to work with the get. So we want to get information from the internet. Exactly.
And now that we've spoken about REST services and we said it's the API that helps us do this, what is it? What is the API and how does it fit into the picture?
So API stands for Application Programming Interface. So it's the set of rules and protocols that is going to allow us as a client to communicate with the server in the internet. How does it work? We define a series of methods and data formats to request an exchange of information. So we have to follow some instructions. And also, why is this API important? Because it enables the communication with servers and with multiple different applications. So that way we save time.
Exactly. And we actually brought example that's a little bit more contextual with us. And this is probably one of the most famous examples to explain what the API is. And this is a kind of an analogy of what happens in a restaurant, right? So run us through here. If we now sitting in a restaurant and we now want to use the API to get data from somewhere.
Yeah, exactly. So just imagine that you go to a restaurant. So if you go to a restaurant, in this case, you're going to be a client and you want food. who has the food? The kitchen. But normally when you go to a restaurant, you don't go to the kitchen and make your order, right? You normally go through an intermediate person, which is the waiter or the waitress, which is, in this case, the API. They're going to bring you a menu, which is all these different protocols, which is this document, and there is all the instructions. So, hey, we are a restaurant of burgers, so you can order a burger. So when you want to retrieve a burger from the kitchen, you go through the API, which is the waiter. The waiter goes to the kitchen, place your order, and then also the API retrieves you the burger, gives you the information.
Exactly. So that, again, that's a very basic way of understanding it. The menu part is also important. It's the documentation part. It tells you how to request it. If you send the wrong request, you don't get anything, right?
Exactly.
That's very important. Okay, so let's actually now go and show this live. We also have another example here about cats, but I'll just give the screen over to Trinidad here, and let's make this a bit more concrete with this example before we actually return to the use case.
Yes, so we're going to present an API service to retrieve cats from the internet. So there's a server, a kitchen full of cats. And if we want to retrieve the cats from there, we just have to follow along the different instructions from this specific API. So here we have what we saw before, the HTTPS, so it's the verb, and they follow the different instructions. So here we actually just copy, and we can copy and paste in the browser. And what we have to change is the status code. So how do you want your cat?
So I like the picture of the cat without legs, so 100.
100, continue. So that's actually how easy it is to retrieve the information.
And the part there at the end, the 100, that is what the order that we created, so to speak, the request that we built to send to the API, right?
Exactly.
Okay. Good. So let me grab back the slides here and return us back to our use case now. Let's leave the cats on the side or on the couch or wherever you are for a moment. And let's go back to apply this now to Zoe's use case. So we already said that we have this data table that we created. We already got some analytics and visualizations, but this could happen, for instance, in Zoe's case, it could happen that they're saying, you know what, we want to visualize not our insights not only in terms of a bar chart or a line plot, but let's actually go visualize it on a map, because this could be interesting and useful for us in making our decisions on which university partner we want.
Mm-hmm.
And for that, and this can happen that you get to this stage of your project and you realize, hey, one more data point can really be useful for us. And now you go and connect via API to get this. In our case, what is going on here? What does Zoe need to enrich the data set?
So she wants to enrich with the latitude and longitude of the universities that she's interested in. So she's going to gather data connecting to OpenStreetMap. So OpenStreetMap, as Maria Claudia mentioned before, is this free open data that is actually updated and maintained by volunteers. And it's very powerful and it's open data. So here we're working with Data Europa, which is open data. Also, we work with data from our world in data, where we retrieve the CO2 data. Now we're going to connect to the server of OpenStreetMap and extract geographical information.
Exactly. So let's actually then break it down and with reference back to our kitchen or our restaurant analogy. Let's start then with how to access it, the actual creating the GET request, and how would this look like starting with the kitchen in our example?
Yes. So OpenStreetMap is going to be our kitchen where the information is stored. And this kitchen has their own set of rules, which is this document, and we communicate with the kitchen with a specific API from this kitchen. So as we mentioned before, every server, so every kitchen has their own set of rules, and it's always very important to read the documentation. So that way you can successfully connect and retrieve the data. So here on this link that we have on the slides, everyone at home can click on it and go directly to the documentation.
Okay, so now we know where we want to get the data from a server on OpenStreetMaps. We know that there's documentation to follow. We got that. Now here's an example of actually now starting to build a request with the documentation and sending it to the API. Maybe you can take us through this as well.
So the waiter of this restaurant is called the nominator, okay? And here we find all the set of rules to extract the information that we need from OpenStreetMap. And actually how we do it is with that search API with the following format. So here, you can see that we have the HTTPS, and then we have the API that is connecting to the OpenStreetMap. And then at the end, we can see that there's like a parameters space. So there is actually where we're going to place our order.
Exactly. And then we get back to the customer, in this case, Zoe, and she's the person that's building this GET request, sending it via the API, nominatum, and that then connects the server, and if it's successful, sends the data, and in our case, on the university's location, right?
Exactly.
Good. Well, we have also broken this whole process down up into visualizing it in 5 steps. Trinidad, what are the 5 steps?
Well, first, we need to send a GET request to OpenStreetMap. So GET is the verb for the HTTPS. So we want to extract information. If OpenStreetMap is nice with us and they retrieve our information, they say like, yeah, okay, you can get this data, we're gonna get a response. This response, we have to read it and transform in the tabular format for file data, because we're gonna see in a couple of slides how is the object looks. So this is a GeoJSON object, but it's basically a JSON object with geographical information. Then we're going to transform the latitude and longitude into a geo data point. So that way the tool that we're going to use today can read this information to, at the end, visualize the location on a map.
Exactly. So we get the response as a data object, a JSON object. We don't work with that. Recall in session 1, we also worked with JSON objects. We'll recap that in a second, but you have to transform it to a table because that's what we use. And there you already mentioned GeoPoints. This is a new data type. We'll explain it in a bit later in detail, but it's very important to understand when working with geo data that it's a category by itself.
Mm-hmm.
All right, so let's go through the 5 steps in more detail and show how to actually get the locations via the API. So step 1, Trinidad.
So, well, Zoe has to send a request to OpenStreetMap. Yep. So she's going to follow the information like from the documentation. The menu has a certain set of rules. And in the parameters part, she's going to input the information of a university. So here we have the example of Piazza Leonardo da Vinci, Milano. So this is the information from the Technical University of Milan. And at the end, we have which format we want to retrieve the information, which in this case is going to be a GeoJSON.
Exactly. So that's how it would look to build the request. Step 2, if successful, Zoe gets a response. And the response, depending on if you open in a browser or in a tool, would look something like this.
Mm-hmm.
And this is the JSON or GeoJSON object that we were speaking about, correct?
Exactly.
Then let's go to step 3. Now that Zoe has gotten a response, she's got a JSON object, what needs to happen now?
Well, as you can see, is in this GeoJSON format, and we need it in a tabular format. So we need to include it to our data set. So what we're going to do, we just select those points and we add it as a column in our data.
Exactly. So we enrich the data that we already have so that we can go plot it later. And this is really important. This is where the tools of the BDTI framework again plays a role, because you can maybe request one data point via the browser, like the cats. But when you start working with big data sets and you want to do multiple things, then a tool becomes really helpful.
Mm-hmm.
All right. Step 4, as we said here, we have the 2 columns. That's the data points that we got from the JSON object, but they are not yet in the correct data type, because we already said there's something else going on here, right, Trinidad? What's going on?
Yeah, so here, for the tool that we're going to use, we need to transform the latitude and longitude into a data point, so a geometry point. So that way, in the next step, we can plot it in a map.
And speaking of geodata types, let's take a second and just quickly go through these ones. The ones that are important for our use case and the ones that people should be aware of, but it's probably not relevant for this specific use case.
Yeah, exactly. So we have two main geodata types, the vector data and the raster data. Raster data, we're not going to touch it today because for our use case, we are going to work only with vector data. But vector data is basically points, lines, and polygons. So a point is a single location. So as a university, for example, we will have the latitude and longitude that gives us a point on the grid. Perfect. Second, line. So linear features, a road, a river, so these geographic forms. And the last one is the polygons, which are actually polygons. So areas or regions like a country, a lake, etc. So today we're going to work with points because we want to locate universities on a map.
Exactly. Then when you got your data and the correct data type, now it's possible to map it on a map like this. But Trinidad, this is not a normal map. It's not just where you plot points to show locations. What is going on this map here?
So here in this map, we have the location. But as you can see, we have bubbles with different size. So here we have another layer of information, not just the geographical information. We have all the information from Zoe that she's been working from session 1. So we're interested in universities, projects, energy projects, and have this difference per country. So here in the map, we can put together the different layers of information, but visualize it on a map. So that way we can compare, we can have this comparison power on the country level.
And we'll get back to this in more detail in a second, but the size of the bubble, for instance, here indicates the amount of projects that university is busy with, and that could be a first visual guide to say, let's go look at that university. But importantly, here's a new dimension we added here, and it's the overview of where these universities are geographically located. And it could be in the use case of Zoe that let's say her university is somewhere based in the north of Europe, that they have incentives from the rector or the funding schema within the university to now create partnerships with someone from the south or from the east or west of Europe. So this is also a way of then bringing that dimension in, so you can quickly now map 4 dimensions, which is now the location visually on the map, but also the amount of projects, the geospatial, the CO2 emissions, and the amount of projects per country. So you can map all these things together in one. As we have said before in different sessions, and the same here, if you want to do your GET request, you can do it using any of the tools in BDTI that's available for this. Here, if you are proficient in scripting, you can go do it with Python and R. In a moment, we'll demo this with Nime Analytics platform, but this is really up to you. With that, Trinidad, I give you back the screen.
So let's go live with this. So first, I want to show you one single GET request on the browser. So here we have all the information that we showed before. So the nominatim, OpenStreetMap, the search, and the specific location we're looking for and in which format we're going to get it. And this is actually a response. This is the response that we saw on the slide. We can just go and do it in the browser and get the response. But for our use case, and as you mentioned before, we need to manipulate this data and work with it. So we're going to use a tool. And we're going to keep using Nime Analytics platform because we have been using that one on all the sessions. And we're going to start with one static example. So actually, what we see here, we're going to do it within the tool. So the operation that we need to do is a GET request. So we just have the node GET request. We opening the configuration and we put the URL, the specific URL with all the information that we want. And then we retrieve the information from the web. So we can actually go live, clicking here, now is communicating with the web. And we can see that we have a response, which is not showing. Here we go. So we got a status 200. This means, hey, your request is well received, you can get the data. Nice. Then we have the content type, which is the JSON and the formatting of the JSON. But what is important for us is the body of the response. So here we have our JSON object. And as we saw on the first session, we need to transform this JSON object into a tabular format, right? So what we're going to do, we're going to come back to our JSON path node. So here we have the JSON object. And remember that we have a key, which is the name of the column, for example, and the values. So here we're going to select the latitude and the longitude, and we're going to give it meaningful columns names, so that way we can integrate it with our data. Now, if we see the output of the JSON path, we see that we have the longitude and the latitude in the tabular format that we needed.
And that's basically step 1, 2, and 3 that we showed so far. Yeah.
So now let's jump into step number 4. So to keep working with NIME Analytic Platform, we need to transform the latitude and the longitude into the geometry data point. So here we just select the latitude column, the longitude column, we click in OK, and we transform this data into the geometry data point. So here we keep the information, we keep the longitude, we keep the latitude, but we add the data point in a geometry data format. And now the fun part, we put this on a map. We're going to see for the first moment now, just a specific, like a generic location. We can see that it's like a very tiny point, but here we're seeing OpenStreetMap and a specific location.
Okay. Now we saw how to do it with a new point 1.1 request, and this is just to plot the location. But let's say in Zoe's use case, we have a data table already, and now for those universities, and this could be multiple, how can we do now exactly this, but enrich that table with the locations of those universities, and then plot all the data together?
Let me go the other way around. Let me show you first the plot that we can have. So our geospatial view. Well, it's going to take a while because we have to run it. But basically, we can grab the information from before. So here we're filtering 30 universities based on the number of projects. So we sorted before. Do you remember? We sorted by descending order based on the project. And then we select those universities. Now that it ran, we have our final visualization, which is the map with all the information of the universities and the countries. But how did we get here? As I was mentioning before, we filter the units that we wanted. So in this case, the universities with the most amount of energy projects. We do a pre-processing step here, which basically we are going to generate the URL because we didn't have it before. So now we're going to map the street, the country, postcode, and everything. All the information for to do all these steps are in the exercise. So we're not going to go on detail now. But what is meaningful here is that, for example, here in the row filter, we didn't have a URL column, right? But after we do all this data pre-processing, we're going to generate a column that we're going to input as a URL to communicate with OpenStreetMap.
So basically what we're doing there in that meta node, which you can explain to us in a moment what that is we just step for step building that GET request where you saw, where you add a bunch of word strings to each other in that URL to actually say, hey, I want the address for this university, right?
Exactly. Yeah. So instead of like typing one by one, you doing this workflow, you can generate all of this automatically. And coming back to the meta node, which is this box, is only to hide complexity. So instead of having like a big workflow with everything, you can grab the nodes that you want and give it a meaningful name, which is the data process, pre-process, and put it in a box, which is called this meta node. And now this meta node, we can connect it with the GET request. Now, if we open the GET request, instead of manually input one single URL, we're going to select a URL column. So the column that we just generated with all the different addresses, we're going to input it here. And this is the same operation if you work with another tool. So for example, with Python or with R, what is called the for loop. So in a for loop, you go and you select one by one. Instead of doing that, here we just select the column and the program automatically is going to go through each of the generated URLs.
So basically you choose a column and automatically for that whole table goes look at that column row by row and gets or executes the GET request.
Exactly. Yeah. If we open our GET request results, we have the status, so we have the URL, the status, and our GeoJSON response, which we need to transform into two columns. So what we did here, we read it with the JSON path. And here you can see how we are enriching this data set. So we have in one column the name of the university, the CO2 emissions, number of projects, and the information that we didn't have, we generated and we extracted from the website. And now we have the longitude and the latitude of our universities. We can see that sometimes the information, by different reasons, we're not going to be able to retrieve it. So in this case, we have missing values that for simplicity today, we're just going to filter them. So we filter them here. We don't see them. So we ended up with 25 universities. And now we transform it to latitude, longitude into this geometry point. And last, not least, and super fun, is that we have the geospatial view node where we can configure it depending on our needs. So in this case, for example, we have the marker size. So the bubble is depending on the CO2 emissions. But if we change it and we want to do our analysis based on amount of projects, we can just change it. And we can see how the bubble size is going to be different in this case. So now the German bubbles are smaller because we have bigger, more projects in this university in Denmark, for example. And now we can also select on the different configurations. So, well, the basic is select the geometry column, which is the different points, our vector data. And then we can see, okay, marker tooltip columns. So here's like when we hover on top, what information we want to display. So in this case, we want to display the country and the CO2 emissions. But then if we click on it, we have the name of the university, the total project cost, the amount of projects, and the specific topics, which is in this marker pop-up columns. And also we can select the color of the column. So here, for example, we have the marker size depending on projects, and let's map it the color depending on countries. So we're going to have different bubble size, but with the same color in each country. So here, for example, in Denmark, we have a big bubble because it's based on the amount of projects, and a small one because because of the same, but with the same color.
Exactly. And again, just another reminder of this, it's so important that the domain expertise, the subject matter expertise starts to inform what you choose to show here and how these data points or these visualizations gets interpreted. Because in the end, you need to have the balance between the data and technical side and the decision-making contextual side.
Exactly. Let me go 1 second more. So now we enrich all this data, and we're going to connect this tool again with the PostgreSQL. So we're going to push this data that we just collected, and we're going to store it in our database. So same as we did 2 sessions ago, we just need to connect to a PostgreSQL connector. So here we input the credentials, we connect, and we do a DB writer. So we're going to write here, in this case, a new table in my same database that is going to contain all this enriched information from the universities.
Yeah, exactly. And again, you can either write it into a CSV file and send it by email if it's small enough, or if you want to have a central repository where different people can access it, a database is a good way to go, and this is how you would, again, in good practice, store it there for other people to access. Okay, let me grab back in the screen from Trinidad, and then let's just recap the 5 steps, which is basically the same for all tools that you could use. Step 1, you want to send a GET request, so you have to build your GET request and you send it off, in this case, to OpenStreetMaps. Then if you're successful, we saw some of them were unsuccessful, and you can see it with the status. Go check the documentation, 200 successful, 400, maybe it gets too long and it gets bounced or something like that. If it's successful, you get a response. In our case, it is an JSON or GeoJSON object. Now, we can't work with that data in our table, so we need to convert that to a data table. And actually enrich, in our case, append the columns so that we enrich our data table. And we saw, since the longitude, latitude numbers, we had to convert it to a new data type, which we introduced to you today as well. And then we were able to take our aggregations from the previous sessions and also plot them together on the map. So that's the 5 steps that you can go and try and practice for yourself. It's very powerful, and it's the same thing. If it doesn't matter what data you're going to use, it's basically the same steps you'll have to follow. Trinidad, let's just summarize before we get to the recap of the whole webinar series. If people go and do the exercises, go watch the recordings, everything is available on the GitLab repository. What should the people be able to do?
Well, same as in every session, sign in into the BDTI framework and initialize the tools that you want to work. So today we work with 9, pgadmin and PostgreSQL, because we connect these tools. Then understand the fundamentals of the REST services. So now at the very beginning was something completely that we don't know. And now we are clear with this kitchen customer API, what it is. And that way we can gather the data from the internet and enrich our data. Then everyone at home should be able to reproduce this and retrieve geospatial data using the Nominatim API. To then append this geospatial data to our dataset and visualize these data points on a map.
Exactly, and we also brought another bonus information with today. Let's say you want to go and enrich your data table with additional information on the universities, not geolocations, for instance. You can do that with something like the API from Wikidata. What is it? How does it work, Trinidad?
Well, so Wikidata is the server that contains all the data from Wikipedia. So it's also open data, so same as OpenStreetMap, same as rolling data, same as Data Europa. So you can go and retrieve this data. And here on the link that we left on the slides, there are the instructions on how to communicate with this specific kitchen, which is the Wikidata.
Exactly. And just imagine you want to append another column there, maybe something like the total amount of students per university, if that's important for your use case. This would be a way then to go collect that specific data point from with the API and append it to your data set. Okay. Let's now quickly take the next 5 to 10 minutes to recap what we did over very high level, what we did over the last 5 sessions. Starting with the use case, we should know this very well by now. Quick summary, Zoe, she's from education department at a university, and her university is in a region that's highly polluted or has a lot of CO2 emissions. So therefore, they've decided to apply for funding, but they want partner universities to work with. So they need to strategically choose one of these partner universities. In order to do that, so they wanted to go look at what type of projects they were in the past, what was the funding there, what is CO2 emission of the countries. They want to collect a bunch of data in order to get insights to inform their decisions. This is basically the gist of the use case. And for that, they wanted to build a report or a dashboard that they can use to then guide their decision making. Now, as we saw, we divided this data process or this data pipeline that they built in order to get the insights in 5 sessions. Now, session 1, Trinidad, take us back to the start. Now that we know what they wanted to achieve, how did this all start? And again, this is a generic process. This is basically the same for any data project that you work on, these 5 steps. So you can go and apply it to any other use case. Starting with session 1 or step 1, what was happening there?
So the goal of our session 1 was to access the data from multiple sources. We had different sources, and we explored to make decisions based on the objectives. So as you just mentioned now, Zoe had this plan and this big goal. So how she's going to do it? With data. Data sources and format, we work with dataeuropa.eu, and the data came in different formats, 5 formats, so CSV, Excel, and JSON. And in the first session, we introduced 3 of the tools, which was Jupyter Notebook using Python, RStudio, and then NIME Analytic Platform.
Exactly, and the data from the European Data Portal, that was from the Horizon project, and we had a bunch of files that we downloaded there. And now that you've accessed the data, Trinidad, the next step is always to clean and transform, because as we all know, data is really, really clean, right?
Yeah.
So quickly take us through what that entailed and how it fits into the BDTI framework.
Yeah, so in session 2, we learned that the real world data problems is that raw data never comes clean. So here is where we start doing our using our new powers. So here we learned how to clean and transform the data. So we made decisions like, I don't need these columns, so we're going to filter those columns, or I don't need these rows, so we're going to filter those rows. And also, we transform the data on a table shape. So we add columns. For example, we add the starting years of the projects. And also, we transform the data on a cell level. So we introduce in that session the different data types, so numbers, string, dates, and we transform the data when it was needed to the correct data type.
Exactly, and this is very important, not only to get rid of the unnecessary data that you don't slip it along, it becomes a big problem, especially with big data, but then transform it into the right shape. And that is very important for the third step, which is blending your different data sources. Now, if you recall, we had, I think, 8 different data files, and that also is to do with the fact that the Horizon project has 2 funding periods. So we had per data set 2 files, for instance, which is very important. This can happen when you look at historic data. And that was a perfect use case. It was the same data table with the same structure. That means the same columns for 2 different periods. And we could stack the tables nicely on top of each other. It could also be that you need additional information from another data set, and that's where joining is really useful, where you add a column or append columns when you're in your joining operation. And therefore, the transformation in session 2 is very important to get in the right shape in order to do these types of joins and stacking. Now, after that, what happens next?
Well, then we export in the data format that we needed. So it's very good to export it always in CSV, because as it is open, everyone can open it depending on the tools that they use. And also we saw the case that if the things goes too big we can store all this information in a database.
Exactly. Good practice to have a central repository. It's also good data governance. And all these tools are, again, available in the BDTI framework, which means if you don't have a database somewhere, you can have it on the framework, or if you don't have the computer capability to work with big data sets, this is really where the tools and the virtual machines start to integrate and really play along nicely. All right, so now we've blended the data, we've stored it. In session 4, this is what we recapped at the beginning, but that's where, to quote Maria Claudia, things get exciting, right? Because now you've done the hard work, the most important work in steps 1, 2, and 3, in session 1, 2, and 3. It's not as exciting, but it's probably the most important, because if you don't have quality data, you don't get quality insights. But if you did the first 3 steps correctly, now the exciting part comes where you start getting insights from that. So we looked at some aggregations, how to summarize your data, how to summarize your data with different dimensions, how to pivot things and start visualizing to get the patterns that are hidden in the tables. And we also showed you how to do this with a report or a dashboard. So there's multiple options for you then to start communicating your insights with the decision makers. And again, here's the contextual level and the data technical level coming together. And there needs to be a balance. If there's not a balance, then things go skew very quickly. What are the tools that we were working with here, Trinidad?
So on the last session, we used Apache Superset for dashboard creation and nice visualization. We store the data, so we retrieve the data from pgadmin and PostgreSQL, and then we ingest that data to Apache Superset and also to NIME Analytics platform.
Exactly, and that brings us now to today's session. And as we mentioned, sometimes you realize when you get to your, let's say, your visualization part of your project or your aggregation part of your project, hey, we actually need one more data point, which will really help us to make a decision or guide our decision making. And Trinidad, take us through quickly what we did today. Again, how do you enrich your data set, in our case with geodata?
Well, so today we learned the superpower of connect to external data sources with connecting with the internet using the REST protocols and open APIs in this case. So we use OpenStreetMap, we connect to that server via nominatim, and then we extract the latitude and longitude to plot it in a map.
Exactly. And I'm going to repeat it again. These basic steps, these 5 steps, is really generic for any data project you're going to work on. So the skills that you learn in the BDTI webinar series are really transferable to other projects. Your data sets might look different. There of course will be some differences, but the high level process and best practices that is attached to that stays the same. And this is really valuable to understand when we look at a diagram like this. Then, as we always recommend people to acquire these skills, to really get used to this process that you've learned over 5 sessions, because working on data projects is a process. It takes a long time to get to these valuable insights. We recommend that you practice. We have all the recordings, exercises, slides, and additional resources available on the GitHub repository. We also have, for today's session, exercise that people can download. The solution is there as well. Please do that. We recommend that to really get used to the framework, the BDTI framework, to get used to the tools, but also the concepts, the data concepts that were introduced during the 5 webinars. With that, we want to bring back Maria Claudia for the Q&A, and I know there's some next steps that she would also like to highlight after the Q&A. Thank you, Maria Claudia, back to you.
Thank you. Thanks a lot, Trinidad. Thanks a lot, Skalk. I think it was, again, a really interesting, inspiring session. And I hope that also our audience really enjoy. I don't see any Q&A posted in our widget, but I receive by Alan a private request. Maybe this was just not easy to find the Q&A widget. And he was asking if you can tell us again a bit more about geo-visualization you can do using NIME. You were basically trying to point and to map different points on a map. Maybe we can also, I think what he's looking for is more information on how to visualize geodata, for example, polygon. So I don't know if you can elaborate a bit on this, if you have some input to share with the audience. Thank you.
Thanks, Maria Claudia. Now, I'm not an expert on visualizations. I know it's possible to do the polygons as well. Trinidad, can you grab this question?
Well, we don't have ready for polygons, but what we can really do is share all the information, how to do it with KNIME. So we have all the cheat sheets and the extra resources. So then they can do it at home and apply it. So yeah, we really encourage everyone at home to keep doing it.
So in other words, we'll post, we'll follow up on this, and it's definitely possible. We'll give you the resources. We'll post that in the forum afterwards, so that it's really possible to go and look at that in detail.
Yeah,
that helps, Maria Claudia.
Thank you. It helps a lot. Also, if I may integrate, usually, as you know, we are also offering other tools. And for example, if you're using open source tool like Apache Superset, the one we already used last time with Julian, you can easily map polygons, because once you have, again, in a database or somewhere, the information about the geographical shape of the area you want to represent, then you can easily plug this information in a dashboard. For example, it's when you want to visualize regions or maybe member states, it's going to be very quick and easy to render a map on using polygons. And you can find a documentation also on our website if you check for Apache Superset.
Exactly.
Thanks a lot. So I would say let's move on to the final wrap up. I don't see any other question. So first of all, congratulations. I mean, for the people that are really following every session, I think you made a great job. I hope, and we hope, that you can reuse your findings and also what you learned during these 5 sessions in some amazing project with your colleague. So just to remind you again, we already went through this BDTI Essential course. This was a really basic course for data beginners, but as Skalk was mentioning, what we learned together is really useful and highly reusable for, I would say, every data journey you want to investigate. Now it's about you. It's about brainstorming possible amazing use case you want to implement in your public administration. And then once you have an idea, you can just go and apply for BDTI. Everything is available in our website. And if we move to the next slide, I want to remind you another time, what about eligibility? We mentioned this many times. So if you are a public administration, that's the only mandatory condition. We need a public administration applying for the BDTI use case and the BDTI platform. But we are more than happy to have partnership between the public administration and maybe with academia, students that are doing their PhD or master thesis, and also with private sector. In case you have any doubts, don't hesitate. This is our functional mailbox. Just drop a line there, and also check our resources in our website. For this, if we move to the next slide, I just want to recap about this, a quick info about this BDTI canvas. It's a basic, I would say, toolkit. You can use this just for your brainstorming session in your team in order to start drafting your idea. You have some important dimension that usually you need to check when you are creating a pilot using data. So you need to discover data viability, you need to understand a little bit better about data interoperability, also which is the added value you want to create with your use case. Okay, so that's just a quick reminder about our toolkit that you can find in our website. And finally, if we move to the last slide, we want to really, again, thank you for your participation. And also we have a small I would say, gift for you. So people that attend all the session, you will receive a nice gift, and you will have free access to all the KNIME learning resources, also courses and ebooks. We will send you this code with all the information in the next week, so you can go and enjoy all this material and really try to move forward with your BDTI use case. I think that's all from for this part. In the meantime, I see another question. It's about APIs. I would say yes, we can re-explain REST API. We can also share additional resources in our GitHub repository. So thanks, Aurora, for your question. Final slide. Thank you, Skalke. Here you can see our QR code. Just scan them. You will be redirected to our website and also to our Join Up and newsletter. Feel free to jump us, to drop a line. Feel free to contact us. We are more than happy to discuss with you your use case and to have also one-to-one session in case you are a public administration.